This is section 4.7, part A, the laws of sine and the laws of cosine. A triangle that is not a right triangle is called an oblique triangle. We're using the law of sines to solve these types of triangles. So law of sines can be used if the measures of two angles in a non-included side, so angle, angle, side, or two angles in the included side, or two sides in the non-included side are known. To use the law of sines, it's first important that you label your triangle appropriately. Side A is always across from angle A. Side B is always across from angle B, and side C is across from angle C. But the law of sines is just a proportion. You will only ever use two of these at a time, but we know that the sine of angle A over side A is equal to the sine of angle B over side B, and we also know that's equal to the sine of angle C over side C. We need to solve the triangle ABC, rounding the side lengths to the nearest tenth and the angle measures to the nearest degree. Now, right now, we know angle B and side B. We have angle A, so we can find side A. So I know that the sine of 103 degrees goes with 20, as the sine of 35 degrees goes with side A. Now you do need to make sure your calculator is in degrees before you try to solve one of these problems. But once this proportion is set up, we can just cross multiply and divide, and we'll get that side A is equal to 11.8. Now to find angle C, since we already know two angles on this triangle, we can just do 180 minus 103 minus 35 degrees, and we'll find that the measure of angle C will just be 42 degrees. Once you know that angle, we can set up another proportion to find side C. So again, I can say the sine of 103 degrees still goes with 20. This time, I know that the sine of 42 degrees, because this was 42 degrees, I know this one goes with this side, so I can find side C. We will cross multiply and divide, and we can find that side C will equal 13.7. Now, if we put these on to our triangle, we can actually make sure that they make sense. Because remember what you learned in geometry, the smallest angle should be across from the shortest side, and the largest angle should be across from the longest side. So these answers do make sense in the context of this triangle. An Earth orbiting satellite is passing between the Oak Ridge Laboratory in Tennessee and the Langley Research Center in Virginia, which are 446 miles apart. If the angle of elevation to the satellite from the Oak Ridge and Langley facilities are 58 degrees and 72 degrees respectively, how far is the satellite from each of the stations? So we're just trying to find those A and B values, where A is the distance from Langley and B is the distance from Oak Ridge. Now, right now we know this angle will go with this side. We know that this angle will go with this side, but we don't know any of those angles and sides. But we can find this angle up here because in a triangle, we know there's 180 degrees. I've already used 58 degrees and 72 degrees. So that's going to leave you with 50 degrees up at the top. So this 50-degree angle will go with the side that has a length of 446. So I can say the sine of 50 degrees goes with 446 as the sine of 58 degrees goes with side A. To solve this, we're just going to cross multiply and divide, and we're going to end up with side A is 493.7 miles away, and that's the one that's away from Langley. We can set another one up like this. Again, we're still going to start with that sine of 50 degrees, goes with 446 miles, and we can do the sine of 72 degrees, goes with side B that we are missing. We will cross multiply and divide once again, and we're going to end up with B is equal to 553.7 miles away from Oak Ridge. From geometry, you know that the measures of two sides and a non-included angle, that side-side angle, or angle side-side, does not define a unique triangle. Remember, it doesn't define a unique triangle because angle side-side is bad. So when given two sides in a non-included angle, we have three different possibilities. It's possible that no triangle exists, we could have exactly one triangle exist, or there can be two different triangles that exist. This is called the ambiguous case. So if we take a look at the ambiguous case, if we are looking at a triangle, we know that we're going to have different things for acute triangles when one of the angles we're looking at is acute than if it is obtuse. So if we're looking at the acute case first, we have no solutions if the value of A is less than B and the value of A is less than H. We will have one solution if A is less than B and A equals H. We will have two solutions if A is less than B and A is greater than H. And if A is greater than or equal to B, there will only be one solution. Now, when you are looking at an obtuse angle for angle A, if side A is less than or equal to B, there is no solutions, and if side A is greater than B, there will be one solution. So you first have to determine the triangle you're looking at if your angle A is acute or obtuse to see which of the rules you need to apply. To solve an ambiguous case of an oblique triangle, first determine the number of possible solutions. If the triangle has one or two solutions, we're then going to use the law of sines to find them. So find all solutions for the given triangle if possible. If no solution exists, we're just going to write no solution. The other thing we do need to note from these acute angle triangles is that to find the value of H, we're just going to do B times the sine of A, sine of angle A. So we first need to look at our A, B, and H values. Now, this one does have a C, that's okay, it's just going to be the other side, but we can change this to a B if we want to. But the thing you just need to understand is that side A and angle A have to go together, but the other side, it doesn't really matter what it's being called. You're just more worried about the two sides, the side and the angle that is together represents your A one. So we do know that the measure of angle A is obtuse. So we're either going to have one solution or no solutions. There is no possibility for two solutions in this case. And since the A value, which is 15, is greater than the C value of 12, we do know there will be one solution. So we have one triangle. Let's let this be angle A. So this is side A. We'll let this be B, this be C. I know that angle A is 94 degrees. Side A has a length of 15. Side C has a length of 12. And now we just need to solve this triangle. We do know the angle A and side A go together, angle B and side B go together, and angle C and side C go together. So let's find angle C first. We're going to start with the sine of 94 for angle A goes with 15 or side A. And we know that the sine of angle C, which in this case we don't know, goes with side C, which has a length of 12. We're still going to start by cross multiplying and dividing to get the variable by itself. But in this case, we're still going to have that the sine of angle C is equal to something. We're not going to be completely done after this step. And we're going to see that this is equal to 0.798. Now, if you remember back from previously in this chapter, if you need to get the angle by itself, if you want to move just the sine, you are going to have to do the inverse. Now, when you have this in your calculator, it is best to use your previous answer to do this part so you get a more accurate answer. And if we find the sine inverse of that 0.798, we're going to get the measure of angle C is 53 degrees. Now, because we know angle A and angle C, we can find angle B. I can do 180 minus angle A minus angle C, and the amount that we are left with will be angle B, which in this case will be 33 degrees. So we do know angle B is 33 degrees. Now to finish solving this triangle, we are just going to have to find the measure of side B. So again, we're going to set up another law of sines. So we have the sine of 94 degrees goes with side A, which has a length of 15. And we're going to do the sine of angle B, which is 33 degrees, goes with side B. To solve this, we can just cross multiply and divide. And since we're just solving for a side, the B is already going to be by itself. And we're going to get that side B has a length of 8.2. Again, we can examine the triangle to make sure those answers make sense. The smallest angle in this case is 33, and it is across from the shortest side of 8.2. The largest angle is 94 degrees, and it is across from the longest side, which has a length of 15. So our answers at least do make sense. We need to find all solutions for the given triangle if it is possible. So right now we do know that angle A is 61 degrees, which does mean that measure of angle A is acute. So we do need to look at the rules for acute. This means there could be no solutions, one solution, or two solutions. We know that the value of A is less than B, so we are going to have to look at the value of H. Remember, to find the H value, you're going to do B times the sine of angle A. In this case, our B is 11, our angle A is 61 degrees. You do need to make sure your calculator is in degrees before you find this, and you will get H is 9.62. Since A is 9, we do know that A is going to be less than H. And since A is less than B and A is less than H, that means there are no solutions for this problem. Now, this one does tell us we need to find two triangles. So we don't have to find the H value. We can to see that there will be two triangles, but we already know it's telling us to find two triangles for the solution. So I'm going to break this into two different parts. We're going to find solutions on one side, and we're going to find solutions on the other side. So it's possible that our triangle looks like this. And it's possible that our triangle looks like this. So this is the original triangle, or the normal triangle we're used to looking at. So this is angle A, angle B, and angle C. It tells me angle A is 43 degrees. Side A is 25 degrees. Side B, or 25 centimeters or inches or something. Side B is 28. And we need to solve the rest of the triangle. So first, we're just going to use our law of sines like we would normally. So I'm going to say that the sine of 43 degrees goes with the side that has a length of 25. And the side of angle B is going to go with 28. We are going to cross multiply and divide. And that's going to tell me that the sine of angle B is equal to 0.76. Remember, if you need to get the angle by itself, you are going to have to do the sine inverse. And we are going to get that the measure of angle B is 50 degrees. Once we know the measure of angle A and the measure of angle B, we can do 180 minus that 43 degrees minus 50 degrees to tell us what's left for angle C, which in this case, angle C will be 87 degrees. So we do know that the measure of angle C is 87 degrees. Now the last thing we need to do on this triangle is just find side C. So once again, we can start with our law of sines. So I'd still know that the sine of 43 degrees goes with side 25, and we know that the sine of 87 degrees goes with our side C. If we cross multiply and divide, we are going to get that side C, in this case, is 36.6. Now, once you have that first triangle figured out, they're all acute angles, we can then go over and try to figure out the second triangle where we will have an obtuse angle. So we have angle A, angle B prime, because this is a different one, and angle C prime. This is still side A, this is still side B, those have not changed, but C prime will change. We still know that angle A is 43 degrees, side A is 25, and side B is 28. Now, to find B prime, you are always going to do 180 degrees and subtract whatever you got for your B value on the acute triangle. So in our case, our B prime is going to equal 180 minus that 50 degrees, which will be 130 degrees. So the measure of angle B prime is 130 degrees. Now we can find angle C prime, which is just 180 minus angle A minus angle B prime. And that's going to leave us with the measure of angle C prime to be 7 degrees. Once we have that angle, we can now find side C. So I know that the sine of 43 degrees goes with side A, and I know that the sine of 7 degrees goes with our new C prime side. If we cross multiply and divide, we are going to get that the side of C prime will equal 4.5.